Okay, and the second question, similar sort of thing. It wants to know the desired values between the mean here and the third standard deviation there. So, what is the chance of a value lying within there of the distribution? So that's from the mean to the mean plus 3 standard deviations. Okay, so in order to do this, what we just think about is, well, hang on, the bell curve is symmetrical, so we can use cumulative probability to derive our answer. So because 50% of values will lie to the right of the mean, and we know that after 3 standard deviations it's 0.15%, or as a probability 0.0015, then we are able to work out what the probability is of a desired value being in that range. So 0.5, which is the probability of it being to the right of the mean, subtract 0.0015, which is the part of the right of the mean that is actually outside of the 3 standard deviations, is our probability. So therefore the probability equals, and it will be equal to 0.4985. And that gives us an example, that shows us essentially what probability there is for a value to be in that range specified there, from the mean to 3 standard deviations right of the mean. Okay, so let's have a look at some actual contextual problems behind this. So I'll just clear the board here, and we'll have a look at someone going to work, for example. So let's say I was going to work and I started my journey at 8 AM. And let's say it took me an hour to get to work as my mean time, and a standard deviation of 5. Well, I could work out that plus 1 standard deviation from the mean would be 55 minutes. And from there on, we can actually work out the values there. So let's say that my work actually started at 9 AM. So what would be the probability that I would actually rock up to work late? Well, if it takes an hour to get to work, then I will be there on time, because I leave for work at 8 and I arrive there at 9. So we're looking for values beyond 1 hour. And what we do is we look at the probabilities here, and again we just use that technique, 0.0235, and that's 0.0115 as a probability. Again, we just move the decimal place to change it from a percentage to a probability, because probability values between 0 and 1. And we know that beyond 2 standard deviations, the probability is 0.025, which is also the same as saying 2.5% probability of me being late for work. Okay, so that's quite interesting there in itself. It gives us an example of essentially how I can actually work out whether I'll be late for work or not based on some mathematics I've recorded. Originally this may have been a data set or some numerical data that we've taken and we've interpolated. So now the next question asks, if I work 250 days a year, how many days will I actually be late out of that given amount there? So in order to do this, you can just take out your calculator, and you know that there are 250 days in a year, so 250 divided by 100, and that gives us 2.5 equals 1%, so 2.5 days equals 1%, and I think it's easy to work out using percentages. If you want to use probabilities, that's fine, but again, 250 equals 100% of days in the year, so 2.5 equals 1% of days in the year. So I just go 2.5, and then I multiply that by how often it is for me to be late. So in this case, it is again 2.5. So 2.5 times 2.5 gives us 6.25. Okay, so therefore I can conclude I will be late for 6 days a year. Hopefully my boss doesn't mind too much about that, otherwise I might be actually getting probably not a promotion, but actually being kicked out. So 6 days a year, perhaps that's reasonable, but again, it shows us how we can use statistics in order to solve problems using the standard deviation. Again, I just used the data and how it was distributed to be able to come to that conclusion. Okay, so now let's have a look at another example. So, the next question says, and I'll probably pick a nice interesting one, but it says the weight of hen's eggs is normally distributed with a mean of 65 grams and a standard deviation of 6 grams. This is going to be 71 there, because that's plus 6. Therefore, that's going to be 77, and therefore 77 plus 6 is going to make 83. So 65 take 6, that's going to be 59. Again, this helps if you can actually draw it out and have the percentages put in there, because it easily shows you graphically what's going on. So it's up to you how you like to work out these questions. But now the question says, after that, determine the probability that a randomly selected egg has a weight greater than 53 grams. So we're looking at greater than this. And we're looking at probability. So again, we can rewrite these last two as probabilities. That's 0.0235 as a probability, because again, we just moved the decimal place, and that's going to be 0.0015. Okay, so in order to do this, what we go ahead and do is we say, well, we need to subtract those probabilities from there. So we have 1 being the entire probability across the normal distribution, and we subtract these two actual values here in order to get it. Now what we could do as an alternative is actually solve it using percentages, and then from that we can convert it to a probability. And that's something I might show you now, because maybe that might help you find it a little bit easier as well. So we have 100% subtract 2.35%. Plus 0.15%. Now that is the same as having 100 take 2.5, because 2.35 plus 0.15 is going to make 2.5. So 100 take 2.5 leaves us with 97.5%, and then from that we can rewrite it as a probability of 0.975. That's an alternative way of going about it. If you want to use percentages rather than probabilities, you can actually go through the process with a percent and then convert to a decimal probability at the end. And you can say 0.295% is the probability of an egg being greater than, or having a mass greater than, 53 grams. Okay, so now the next